Hi guys, here's Mr. A again with another solution to another physics problem. This problem is also a projectile motion problem, and I have done one before if you may have seen it. Uh, what uh, what I want to start with is to point out that the most important part of solving a problem is understanding the concept, understanding the basics. So as always, I have a transcript of the solution here, uh, basically to save time. But what I will do as we go is try to explain why what is being done and what is being applied here so that you can actually use the information to solve similar problems in future without assistance. Okay, so let's look at a question. A rock is thrown with a velocity of 11.2 meters per second at an angle of 15 degrees to the horizontal from the top of a cliff that is 42.5 meters high. Okay, so here we are at the top of a cliff, and we know the height of that cliff, and then this rock is being thrown at an angle of 15 degrees. This involves a little bit of vectors, and I'm sure you're familiar with that. So the rock is not only going horizontally but also vertically. So between those two directions, between those two motions, its resultant is 11.2 meters per second at an angle of 15 degrees to the horizontal. So in order to solve the projectile problem, we have to break it down into three parts. One part is the horizontal motion. Another part is the upwards vertical motion, and then the third part is the downwards vertical motion. So it's going up for a little while. So once it's projected from that height, it goes up to a certain height, and then it starts to dip down. But then when it starts to come down, it doesn't stop at the top of the cliff because there is no cliff any further. It's the person that is projecting, or the stone that is being projected, is at the edge of the cliff. So the rock keeps falling even though uh, uh, it falls more distance than it would have if it had just come back to the top of the cliff. So, uh, those three parts we will tackle individually. And uh, again, to be sure, remember that all projectile motion is under the influence of a single significant force, which is the force of gravity. So that the acceleration that the object experiences is only in the vertical direction, none in the horizontal direction. So as it goes up, the force of gravity is pulling it down, and so we take the acceleration due to gravity as negative. And then once it reaches the peak and starts to come downwards, we take the acceleration due to gravity positive. And that is why we have to divide the upward and the downward motion, because the acceleration it has to be a different direction. uh, Essentially the force hasn't changed. The force is acting downwards throughout, but because of its opposition to the direction of motion, when it's in the first part, in the upward part, the acceleration is negative because the object is slowing down. As it goes up, it slows down, and then when it starts to come down, it speeds up. And that negative is really just indicating the uh, way the velocity is changing. So if the velocity is decreasing, acceleration is negative. The velocity is increasing, acceleration is positive. Okay, let's go ahead and get on with the solution now. So let me pull this up a little bit. Okay, so for the upwards part, remember that the velocity is 11.2 meters per second along a direction that is 15 degrees to the horizontal. Okay, so because it's 15 degrees to the horizontal, we apply our little vectors or trigonometry if you want. then the velocity in the vertical direction will be 11.2 meters per second times sine 15 degrees. And the velocity in the horizontal direction will be 11.2 meters per second times cosine of 15 degrees. If you need further explanation of that aspect, you can get in touch with me and I can explain to you how that is what it is, because that's more about vectors, not so much about projectile motion. Okay, so the initial velocity in the upward direction is 11.2 meters per second times sine 15 degrees. The final velocity is zero because as far as the vertically upwards motion is concerned, the rock is going to attain a certain height, and at that point its velocity will become zero. That's why we are saying that the acceleration is negative. It starts off at a higher velocity and gradually the velocity becomes zero. That is why the direction of motion changes. If it kept on going in the same direction, if the velocity never became zero, the object would never return back to the Earth. Okay, so the final velocity is zero, and the acceleration, like I explained earlier, is negative 9.81 meters per second squared. And we're using equations, kinematic equations here. I have written the equation down. If you don't understand how we get what we get, again, that is something that you need to get in touch with me, and I can produce another lecture, another video to explain that. So if you can send me specific questions, I'm always happy to answer them as videos. Okay, so T1, which is the time it takes to reach its highest point, is given by Vf minus Vi over G, and the distance it travels in the upward direction. Remember, we're not talking about its horizontal motion here. It's all vertical. So in the upward direction, the total distance traveled is going to be given by Vf squared minus Vi squared divided by 2G. Okay, and once you solve that, and I'll let you take care of that because that's just plugging numbers into the calculator, and it comes out to 0.30 seconds. So that is the time it takes to reach the highest point only. This is not the total time of flight. Remember, this is just the amount of time needed for it to reach its highest point. How high does it go? It goes 0.43 meters above the level from which it was thrown, or the level of the cliff. And once again, that equation's up there. If you want to use that equation with in your calculator, you should be able to find that the distance is 0.43 meters per second. I am using two significant digits here, considering that 15 degrees is two significant digits. So that's why the answers are all reduced to two significant digits. Okay, coming down to the second part, the downward part, once it's at the top and its velocity has become zero, then it starts to fall. Fall freely under the force of gravity. And that part of the motion means that the initial velocity is zero. Final velocity we don't know because we don't know how much it's going to fall all the way. However, since we have determined that the distance fallen, or the height that it gains is 0.43 meters, then it'll have to fall 0.43 meters to reach the top of the cliff. And then because the cliff is 42.5 meters high, the total distance it will fall from its highest point of flight is 42.93 meters. G this time is positive because the velocity is increasing and it's 9.81 meters per second squared. Once again, the kinematic equation for the time of flight from the top all the way down to the ground is T2 is given by the square root of 2 times D. That's not a negative, that's a dot for multiplication. 2 times D over G square root. And that comes out to 8.75 seconds. Once again, you can do your calculation and figure that out. So the total time of flight then, or the time for the thing to strike the ground as the question asks, is the time it takes to go up and then the time it takes to come down. And the total time, therefore, is T1 plus T2, which is 8.75 plus zero point 0.3, and that comes out to 8.85. 8.85, and hmm, no, 8 is comes out to 9.05, sorry. 9.05, and that reduces to 9.1 seconds as two significant digits. Okay, so that is the total time of flight. Now, again, remember that even though the object is not just going up and down, its motion is actually two-dimensional. It's going up and down, and it's also moving along the x direction horizontally. What we are doing is we are breaking it down so as to be able to calculate whatever we are trying to calculate. And that is why we are calculating the way we are. The time of flight will not change. However far it goes along the horizontal is at a constant velocity, which is the cosine of 15 times 11.2 meters per second. That is the horizontal component of its velocity at the time of projection. So that is going to be the constant velocity that it's traveling at. The total time will be 9.1 because that's what we just calculated. And using that information, we'll find the range. But the question asks for the horizontal distance from the base of the cliff at which the rock will land. That distance is called range in the technical language of projectile motion. And so the range will be velocity times time, and that is 11.2 times cosine of 15 times 9.1 seconds, and it comes out to 98 meters. Uh, most of the calculations I have not actually performed. I've given you the answers to the numbers, but I would like you to do the calculations, and at any stage, if you feel that there is an error, which there is always a possibility, even though I have looked over it a few times, but mistakes happen. And so if you find that something is either not making sense, or you think it's incorrect, or you need further clarification, please feel free to get in touch with me. When this video is posted on YouTube, you should be able to access my email contact and be able to get in touch with me. And so I encourage you to let me know how things go. All right, then. This is Mr. A, and I am signing off for right now.